Hello and welcome to this video on building linear models from data. It's recognizing the type of relation between two variables. Alright, so this video follows up the scatter diagram video on building linear models from data. And here we're just going to take a look at a few scatter diagrams, a few scatter plots, and determine what kind of relationship do the variables x and y, do the independent and dependent variables have based on just these ordered pairs that are plotted, this scatter diagram. And for the most part, we're looking to see if a relationship between two variables is a linear one. We're looking for patterns. Do the points on the scatter diagram tend to follow along a straight line? They may not necessarily be exactly a straight line, but do they tend in the direction of a line or some other shape, some non-linear shape? Or is it just a big jumbled mess and we really can't say there's a relationship between the variables at all? Alright, so let's take a look at, I have a little discussion that I ended the last video with. Again, if you saw my last video on scatter diagrams, you saw a little bit of this, but here it is again. So what kinds of relationships are we looking for? Alright, so here are six. Now they're kind of they're poorly drawn. My axes aren't great, but so here's six scatter diagrams, scatter plots with a bunch of ordered pairs plotted. And what we're looking for are patterns. What's the relationship between the horizontal, the independent variable, and the vertical, the dependent variable? Alright, so if we see a scatter plot like the first one in the first row, where you see how all the points, now yes, they do not form a straight line. They're not all on a straight line. But as the value of my horizontal variable increases, you see how the value of the vertical variable, the y-coordinate, tends to be going up. If I draw a line that kind of indicates the pattern there, see how all those points are tending to follow this line. They're not on it, but they're tending to follow in a linear fashion. And in addition to that, that line that I've just drawn has a positive slope, right? And remember, lowercase m usually represents the slope of a line. M is greater than 0 here. And if the points of a scatter plot or a scatter diagram tend upward as you move to the right, they tend to follow a straight line pattern that's going up as you move to the right. Then we say the variables x and y, the independent and dependent variables, have a positive linear relationship. Alright. Alright, and this second one in the first row, second column. If I see a scatter plot like this, where all the points that are plotted start, they're trending downward as I move to the right. They seem to be following along a line like this that's pointing downward as I move right. Again, all the points are not on this line, right? This isn't a perfect linear relationship, but the points seem to be following along this linear direction. They seem to be trending down this linear path. And the line I've just drawn here is a line with a negative slope, right? M less than 0. So if you see a scatter diagram like this, where points, ordered pairs, are tending downward, trending downward as you move to the right, then they would say that the two variables in question have a negative linear relationship, right? Negative because the line has a negative slope. Alright, now all these other ones hopefully you can see the patterns are not linear. Alright, so now these are just 6 scatter diagrams I've drawn here. There's infinitely many possible scatter diagrams, scatter plots you could be looking at. But here's one. If I said, what's the relationship between these two variables, the x and the y here? Well, look at the scatter diagram. Look at the points plotted, all these peach points here. And you can see, they tend upward and then tend downward. It looks more like they're trending on this, it could be a parabola path or a circular path if I drew more, but it's very clear to me just looking at the pattern, right? That's all we're doing in these is looking for patterns. It looks to me that the pattern this is forming or this is following is not linear. All right, it's more parabolic or circular. But we're just going to be for this. I'm pulling these examples we'll be seeing in a second from an intermediate algebra text, where really the question is, and this will be the case in most statistics texts, introductory statistics texts as well, where you'll be asked, do the variables seem to have a linear relationship or a non-linear relationship? And this is definitely a pattern that is not a line, right? So I would just simply say that we have a non-linear relationship between x and y for this scatter diagram. Same thing for this one here. If you follow all the ordered pairs that are plotted, all the points, they seem to be following a pattern that tends upward, then downward, then upward again. More of a cubic pattern, following a cubic polynomial curve or some other curve, right? But definitely not a linear pattern, not trending totally upward or totally downward like my first two pictures. So again, all we're going to say is that the two variables, the independent and dependent, the x and y variables here, have a non-linear relationship, right? Because there's still a pattern, right? In these last two pictures, there's still a clear pattern forming with these points, but it's just not a line. That's all. Same thing for this one. Definitely a pattern, right? Definitely a pattern forming where it's slowly increasing and then really sharply increasing. Slowly going up and up and up, and then really sharply going up. So this pattern of points, these plotted points, these peach points, seem to be following kind of an exponential curve, an exponential pattern. But again, all we're going to be stating is, does it have a linear pattern or a non-linear pattern? And this is definitely a non-linear pattern, more of an exponential. Now, these three, this arch here and this kind of cubic here and this exponential, there was a definite pattern in these. But if you see a collection of points like this last one, this sixth picture, where the points are just all over the place and it's just a giant mess, there's no pattern here. The points don't seem to be following some particular pathway. So I'm not seeing any relationship, no pattern. It's definitely non-linear, right? Definitely it's definitely not forming a straight line. But at least the other ones had a pattern to them, right? This one, and this one had a pattern to them. This one, I'm not seeing any pattern at all. It's just a big jumbled mess. No pattern. You would say maybe that the variables have a weak relationship. Right? Maybe these two variables, the x and y, aren't that related at all. Right? There's not a great relationship between them at all, because they're not forming a pattern like these other five pictures. Right? Okay, so again, infinitely many scatter diagrams you could look at, but just know that for right now, all we're looking at is, hey, when I look at this scatter diagram, all these points that are plotted, is there a linear relationship between x and y or a non-linear relationship between x and y? All right, so that's what my two examples are on. First example I have is, in both examples are the same instructions. It's determine whether the relation is linear or non-linear. And if it is linear, state whether the slope is positive or negative, right? I talked about that first two pictures there, positive linear, negative linear, trending upward or trending downward as you move to the right. All right, so let's look at this picture here. So I got my x-axis, y-axis drawn here, and then all these like peach points, right? These points here are the points on my scatter diagram, points that are plotted, and looks like they're tending downward here, but then tending backwards, like definitely not forming a a nice linear pattern. Now you could say, hey, maybe draw a line like this. There's a line that these are all kind of tending in that direction, and say that it's a forming a linear pattern, but it's a very weak linear pattern. Right? They're definitely not doing this, where they all seem to be around that a particular line going downward. Maybe these points and these points can be on a line, or a bunch of these points could be on a line going downward, but not all of them, right? So if you want to say it's a linear pattern, I wouldn't recommend that. You could say it, but it would be very, very weak. Based on my little solid drawing here, it looks like it's more of an arced pattern, maybe circular, maybe parabolic. But I would say, just looking at this, that the x and y variable have a non-linear relationship. So this is a non-linear relation. All right. Okay, so again, hopefully easy to see. I mean, it takes maybe some experience with this, but you're just looking at a picture, looking at lots of points plotted on the plane, and asking yourself, do I see a pattern, a very distinct pattern in this? Are they tending in one direction or the other, or is there a big curve going on here, big circle, big arc, whatever? All right, just take a close look. All right, so I have one final example, just one last scatter diagram. All right, so again, here's a has to do the same stuff. Determine whether the relation is linear or nonlinear. And if it is linear, state whether the slope is positive or negative, right? So these points, if again, they're not all on a straight line, right? Clearly, if you tried to connect them all, it would be some crazy zigzaggy graph. So don't connect them, right? We're just looking for a pattern. Where are the points trending toward or tending toward? And if I follow along kind of the heart of them, it looks as though they are following this linear direction here. It does look like these have a linear, that x and y have a linear relationship. So it does look to me that these points are very close to being a linear relation. And then this line I have drawn through here is increasing, going up as you move to the right, and that kind of a line has a positive slope, right? So it's a linear relation with a positive slope, or you might just say that the variables x and y have a positive linear relationship. Okay, and that's really it. I just want to do a couple simple ones like that. Really, you're just looking for patterns, right? In a scatter diagram, a scatter plot, you're just looking for patterns. Do I see a pattern in my points? Are they tending in one direction or another? Are they tending along a curve? Or are they just a big jumbled mess and there's really no relationship between them? All right. All right. And as I like to say at the end of these, try the best you can. Do the best you can to try to learn the material on your own before you go looking for help. Find that material tends to stick better with people who have taken the time and the effort to learn it on their own. So read the material, read the author's examples, perhaps even try to work out the solutions to an example before you see how the author did it, and then compare your work with the author's, and perhaps you can learn from some mistakes there. Of course, work on practice problems, plenty of exercises, look up solutions to those exercises when they're available, to check yourself, see how you're doing. And don't just give up after the first attempt at a problem, right? If after several approaches, you've tried it several different ways and you're still not getting it, then perhaps you should read back through the material again. More carefully, more deliberately, take notes, maybe even read through it a third time. Because who knows, on that second or third read through, you might catch something that you didn't catch the first time, or something might make sense because you've worked on some problems. You know what the author kind of wants now, and then reading back through the material, something will make sense that didn't make sense the first time you read it. But if after that, if after several read-throughs of the material and several read-throughs, approaches at problems, um, you're still not getting it, it's still not clicking, well, then it is not a sign of weakness whatsoever to go out looking for help, asking for help. That is what other people are there for. Ask a teacher, a tutor, a friend, someone in the class who you know knows the material well and is willing to help. Look for supplemental materials online. There's loads of it. Look for videos on the subject, such as this one, or plenty of other videos out there that are better than mine. I assure you, you can find them. But just keep at it. Stay persistent. Keep practicing. Don't give up. And I think the hardest thing is to have a positive attitude. People tend to hate math too much, and they're going to continue to hate it if they keep saying that to themselves. So, if you go in with an open mind thinking, I'm going to learn something today, I'm going to enjoy learning this, I'm going to read this, I'm going to take something away from it, use it, have fun with it, try to have a positive attitude, and it's amazing the difference that that can make. Just a quick, a simple adjustment of attitude. Yeah, so stay persistent, keep practicing, stay positive, and just don't give up. And I know you'll eventually get it. And thank you very much for watching.